In this experiment, your goal is going to be to determine the empirical formula of iron oxide produced by burning iron in air. So the iron that's being used in this experiment is steel wool, and it's just being burned in the presence of air, and the oxygen in the air will react with the iron to form an iron oxide. Now, since iron is a transition metal, it can form ions of more than one different charge, which means there's more than one possible way for iron ions and oxide ions to combine. So you'll be determining which one is produced in this particular reaction. So I have a kind of generic schematic of this reaction here, where the x and the y are the coefficients, but we don't actually know what they are since we don't know the formula of the product. But in some way, shape, or form, iron Fe is reacting with O2, which is the oxygen in the air, to determine to produce some combination of those two elements. And you're looking to figure out ultimately what that formula of the product is. So you'll be doing that by determining the empirical formula, which, as we know, determines tells us the mole ratio of each element in a compound. And you'll do that by collecting experimental data that gives you the mass of each element present. So from your experimental data, you will know the mass of iron in grams, and you will know the mass of oxygen in grams that are present in the iron oxide. And then using the molar masses of those two elements, you're able to convert grams of iron into moles of iron, grams of oxygen into moles of oxygen. And then once you have those two numbers of moles, you can find the ratio between them. And that ratio is going to tell you the subscripts in your empirical formula.